Today we are going to discuss about the leveling. The syllabus of the leveling consists of definitions, technical terms, uses, details of level such as dumpy level, tilting and auto leveling staff, temporary and permanent adjustments of dumpy and auto level, the corrections in curvature, refraction, combined and sensitiveness, the reciprocal leveling, collimation and rise and fall methods, the different errors and the precautions to be taken during the leveling. As far as the definition of leveling is concerned, leveling is defined as an art of determining the relative height of the different points on, above or below the surface. The principle of leveling is to obtain horizontal line of sight with respect to which the vertical distances of the different points above or below the line of sight are obtained. The object of leveling. The objective of the leveling is to find the elevation of given point with respect to some assumed reference line which is called as datum, or to establish the point at required elevation with respect to datum. The different terms which are used in leveling are: number one is level surface. It is the surface parallel to the mean spheroidal surface of the earth. Another is level line. A line which is lying on the level surface is called a level line. The horizontal plane. The horizontal plane through a point is a plane which is drawn tangential to the level surface. Next is horizontal line. It is a straight line which is tangential to the level line. Here in this figure, the different terms of the leveling are explained. You can see that over the surface of the earth, the leveling instrument is being placed and the different terms that just I explained are marked on this. For example, level line, the horizontal surface, the horizontal plane, etc. The different terms which are used in leveling are: number one is datum. The datum is an arbitrary level surface from which the elevation of the points may be referred. In India, the mean sea level, which is considered as the datum of zero elevation, is situated at Karachi. The mean sea level. The mean sea level is the average height of sea for all the stages of tides. It is derived by averaging the hourly tide heights over a period of 19 years. The elevation or reduced level. In leveling, the elevation of a point is called as elevation or termed as the reduced level. It is the height above or below. So, height or depth of any point above or below the datum. It is denoted by RL, reduced level RL. This is a figure that will be explained. The different terms which are used in leveling include the benchmark. Benchmark, it is a fixed reference point of known elevation with respect to a datum. So, we have already studied about the datum. So, with respect to that datum, the elevation of any fixed reference point is called as the benchmark, or we can say the benchmark is a point of known elevation. Next, line of collimation. It is a line joining the intersection of the crosshairs of the diaphragm to the optical center of the object glass and its continuation. It is also known as the line of sight. So, line of collimation or line of sight are one and the same thing. Height of instrument. It is the elevation of line of collimation with respect to the datum. If we want to know what is the height of the instrument, so it is with respect to the datum at what level the instrument is placed. Backside, it is a staff reading taken at a known elevation. It is the first staff reading that is taken after the setup of the instrument. So, whenever the instrument is established or set up at a point, the first reading taken is to the backside to the point of which the elevation is known. So, this way we will be setting up, or we will be able to know that what is the height of instrument of particular location. The mean sea level, this mean sea level is explained with the help of this pictorial as well as a photograph. The different terms used in leveling, the terms which are used for the purpose of explanation or writing down the leveling are: number one is the foresight. Foresight is the last staff reading taken denoting the shifting of the instrument. So, when a instrument is set up at a point, before shifting of the instrument, the last reading taken will be called as the foresight. So, for a particular setup, the last reading we will be denoting as the foresight. Intermediate sight. Intermediate sight is the staff reading taken on a point whose elevation is to be determined. All the staff reading taken between the back sight and the foresight are the intermediate sights. So, just I explained that the first reading we are going to take up is the backside reading, and the last reading we are going to take is the foresight reading. So, whatever are the in between readings taken, they will be written under the column of the intermediate sight. So, this way if we write in terms of sequence, the backside, the intermediate sights, and then last will be the foresight. Now, next important term is the change point. The change point is a point on which both the fore and the backside readings are taken. So, when we want to shift an instrument, before shifting, the last reading taken will be the change point. So, with respect to the change point, we will be shifting the instrument. This is a figure which is explaining the different terms that are being used in leveling. The instruments for leveling, there are different instruments with the help of which the leveling operation is being carried out. The important instruments that are used are: number one is the level and number two is the leveling staff. There are few more, but these two are the main instruments which are used for the purpose of leveling. The level and the different types of level. We have the different types of the levels. It is the instrument which is used to furnish the horizontal line of sight for observing the staff readings and determining the reduced levels. So, level is the instrument with the help of which we will be noting down the readings. The readings we will be taking will be to the staff. So, the observation of the scale will be made with the help of leveling of the staff. The dumpy level, it is the most commonly used type of level. The term is dumpy level. It is a simple, compact and a stable instrument. It comprises of the different components. The most important is the telescope. The telescope is rigidly fixed to its supports, hence it cannot be rotated about horizontal axis. This is the example or figure of the dumpy level, which primarily comprises of the stand and the top instrument. The leveling staff. The leveling staff is nothing but just like a scale. The leveling staff are scales on which the different distances are measured. Leveling staffs are of two types. First is the self-reading staff and the second is the target staff. The different figures shows the different types of the leveling staff. The leveling staff, as I told you, that it is nothing but a kind of a scale. The readings are marked just like a scale on this particular staff, and a very well defined thickness, the alternate black and white and red marks are made so that it can be seen from the distances very clearly with the help of telescope. Benchmarks, as I narrated earlier, that it is a point of known elevation. There are four kinds of benchmarks. Number one is GTS, that is also called as the Great Trigonometrical Survey benchmark. The second is permanent benchmark. Permanent benchmark mean that it is a benchmark which is of permanent type, marking level of permanent nature. Arbitrary benchmark is the benchmark which is selected arbitrarily, and the temporary benchmark is for the purpose of starting a survey work. The first reading, as I said, that we need to know benchmark, the point of known elevation with respect to which the other readings will be taken. So, if it is not available, in that case a temporary benchmark is also established on the site. The details of the GTS benchmark. The GTS benchmark are the benchmarks established with very high degree of precision at regular intervals by the Survey of India department all over the country. That is, the location of the GTS benchmarks are to be established very precisely, very high degree of precision, and with respect to these GTS benchmarks, the other benchmarks can be obtained or other benchmarks can be marked off. So, the as just said that it is the developed by the Survey of India department, their positions and the reduced levels values above the mean sea level, which was earlier located at Karachi and now it is taken at Bombay High, Mumbai, and is given in the catalogue formed by the department. So, it is being transferred from Karachi and established at Mumbai. GTS benchmark, this figure shows the details of it. The permanent benchmark. The permanent benchmarks are fixed in between the GTS benchmarks by the government agencies such as the railways, PWDs, etc. These benchmarks are written on permanent objects. So, for the respective departments, it can refer to these benchmarks which are mostly used by the public works department or the railways, so that the work can be done precisely, the levels can be transferred or can be established precisely. These benchmarks are written on permanent objects. The objects which are of permanent nature, there these permanent benchmarks are marked. These are mostly the milestones, the culverts, the bridges, because these are of permanent nature. So, the transfer of the benchmark is done on these points and their values are clearly written and their positions are recorded for future references. For example, this is an example of a station, that is the Jaisalmer station, what the location is, and at that particular location what is the reduced level, that is marked. So, for further references, these can be taken as the benchmark or the point of known elevation, and the levels can be transferred with respect to this. Another permanent benchmark, the survey marker, is also shown. The benchmarks continued. Next type is the arbitrary benchmark. So, these are the reference points where reduced levels are arbitrarily assumed. It is not with respect to the permanent one, but this is arbitrarily assumed, and so they are called as the arbitrary benchmark. These are used in small works, because if a work is not of permanent nature or not having much of importance, in that case, just to establish and the transfer the level or set up the level, the arbitrary benchmarks can be set up. Such benchmarks may be assumed as 100 meter, 50 meter or any such value. So, this is a arbitrary value is given to a point of benchmark. Temporary benchmarks, they are the reference points established during the leveling operations when there is a break in work or at the end of a day's work. The value of reduced level are marked on some permanent objects such as stone, trees, etc. So, when we are working on this, leveling work is being carried out, it may be that we have to provide a temporary break or for a day or two or so. So, a temporary benchmark will be marked on permanent objects like the stone or trees, and then the work for the next day can be started further. This is an example of arbitrary benchmark. This figure also shows the temporary benchmarks which are being established temporarily. The temporary adjustment of a level. Now, when we want to start the leveling work, there are two things. One is the staff and the other is the level. So, when we want to start the leveling procedure, we have to set up the instrument. This is very important and as the first step to start the procedure of leveling. Now, the instrument, that is the level, has to be in adjustment. It should have the adjustment in the vertical as well as horizontal direction. So, to achieve this, there are certain temporary adjustments that are being done to set up the level at a particular station. First is, these adjustments are performed at every setup of instrument. That is, when we are establishing the instrument at location 1, we will be following this procedure, and when we will be shifting to the second station, there also the same procedure of establishing the instrument, adjustment of the leveling will be done. The different steps of establishing temporary adjustment are: number 1, setting up of level. That is, the level will be set up over a particular location as best possible over the point where the reading station is being thought of. Over that, the instrument will be set up. The second is the leveling of the telescope. The telescope through which the readings are being taken to the staff, that has to be at leveled, because if it is not leveled, then in that case at one part of the reading it will be either giving more than required, or at the other part of the level it will be giving the less than the actual reading. So, it is very essential that the telescope has to be perfectly leveled. Then, in order to take the readings through the telescope, it has to be focused. For that, there are 2 points of focusing. One is the focusing of eyepiece and the other is the focusing of the object glass. So, the focusing of these two are also to be done before the start of the observation. Now, the setup of level, as I just told that we have to set up the instrument at a particular location. The setting up of the level includes: number 1, fixing of the instrument on the tripod. As narrated in the figure, the level is established, set up with the help of a tripod at a particular location. So, the instrument will be tightened over the tripod and the tripod will be kept in such a way as far as possible so that it is approximately in the level position. However, in the next step, leveling the instrument approximately by the tripod. So, after setting up of the level, tightening of the base on the tripod, then by visual observation, firstly the 2 legs are fixed and as far as possible leveled, and the third leg is moved either sideways or inside or outside, so that temporary adjustment of the level is done. This is figure showing the leveling of setting up of the level. The temporary adjustment of a level includes leveling with the help of foot screws. After the initial setup of the level with the help of tripod, leveling is done approximately, and later on the precisely leveling of the instrument is done with the help of the foot screws that are placed just below the leveling instrument. So, there we will be first of all setting up the telescope parallel to a pair of foot screws. There are 3 foot screws. We will be placing the telescope over any 2 of the foot screws and then hold the foot screws between the thumb and the first finger. It is kept like this and we turn them either inward or outward. So, the 2 screws are either moved inward or outward simultaneously. This until the bubble, longitudinal bubble, comes in the center. So, we will be moving these 2 foot screws and will see the bubble. The movement is done either inside or outside till the bubble comes to the center of its run. As a second step, we will be turning the telescope through 90 degree. Earlier we kept it parallel to 2 of the foot screws like this, and then it will be turned over and kept over the third foot screw. This is how the 90 degree movement is done. Now, it lies parallel to the third foot screw. Now, we will be turning the screw until the bubble comes in the center of run. So, initially we have done the operation of the parallel or leveling in this particular direction, and then we will turn it 90 degree, and the leveling on the third direction will also be done, or the parallel direction will be, perpendicular direction will be done. Again we will be rotating it, again bringing it to the two parallel foot screws, the same operation repeated. Again we will be rotating by 90 degree over the third foot screw, again the same, that is with the help of the third foot screw, either moving inward or outward, the bubble will be brought to the center. This operation we have to repeat a number of times, so that it will be parallel to the 2, then over the third, then again parallel to the 2, then again over the third, so that it is perfectly leveled in all the directions. This is how the figure shows the foot screws and how the bubble tube is kept over it. Next part of the temporary adjustment, as I told you, that now it is the focusing of the eyepiece. To focus the eyepiece, hold a white paper in front of the object glass and move the eyepiece in or out. That is, movement is to be done such that or till the crosshairs are seen distinctly or clearly we see the crosshair. So, the paper will be kept in front of the object glass and it will be moved so that the crosshair can be seen clearly. Next, it comes to the focus of the object glass. Direct the telescope to the leveling staff or any other object and we will be looking through the telescope. Turn the focus screw till the image appears clear and sharp. So, we are doing it in two steps, that is number 1, focusing the eyepiece and then focus of the object glass, so that the readings can be seen clearly through the crosshairs. This figure shows the temporary adjustment of a level. Now, the permanent adjustment of level. The establishment of a desired relationship between the fundamental lines of a leveling instrument is termed as permanent adjustment. So, the permanent adjustment indicates the rectification of instrumental errors. These include the fundamental lines, the line of collimation, the axis of the bubble tube, the vertical axis and the axis of the telescope. In this, the following relationship between the lines are desirable. It includes number 1, the line of collimation should be parallel to the axis of the bubble. So, secondly, the line of collimation should coincide with the axis of the telescope. Thirdly, the axis of the bubble should be perpendicular to the vertical axis. It is very important. That is, the bubble should remain in the central position for all the directions of the telescope. In whatever direction we move the telescope, the bubble should be at the center. This particular figure shows the details of the different important components, the lines between which the permanent adjustments are being. The permanent adjustment of a level, two adjustments are necessary in the dumpy level. Number 1, first adjustment to make the axis of the bubble perpendicular to the vertical axis. That is, it has to be perpendicular to vertical axis. Second adjustment include make the line of collimation parallel to the axis of the bubble tube. This is being done like following procedure is adopted to make the line of collimation parallel to the axis of the bubble tube. The level is set up on fairly level ground with its legs well apart. It is firmly fixed on the ground so that it does not shake. Next is the telescope is placed parallel to any pair of foot screws, and by running the foot screws either inward or outward, the bubble is brought to the center of its run. The telescope is then turned through 90 degrees so that it lies over the third foot screw. Then by turning the third foot screw, the bubble is brought to the center. The process is repeated several times until the bubble is in the central position in both the directions. This particular figure shows the procedure that we have just narrated. The permanent adjustment of level, second adjustment is done by two peg method. There are two pegs are taken, for example A and B, and are driven at a distance apart on level and firm ground. The level is set up at a point P just midway between the 2 points A and B. After bringing the bubble to the center of its run, the staff readings on A and B are taken. Suppose the readings are small a and small b. Next step is the difference of level between A and B is calculated. This difference is then true difference as the level is set up just midway between the backside and foreside. Then the rise or fall is determined by comparing the staff reading. This particular figure shows the procedure I just narrated. The permanent adjustment, then the level is shifted and set up at P1 very near to A, say at a distance small d from A. Then after proper leveling, the staff reading at A and B are taken. Suppose the readings are A1 and B1. Now next the apparent difference of level is calculated. This apparent difference is then noted. If the true difference and the apparent differences are equal, the line of collimation is in adjustment. If not, then the line of collimation is inclined. Let small e is the staff reading on B at the same level of the staff reading A1. Then e to the power x A1k is the true difference. The permanent adjustment of level, for this use the positive sign in case of the fall and negative sign when it is in rise. If B1 is greater than E, the line of collimation is inclined upward, and if B1 is less than E, it is inclined downward. So the collimation error is calculated in distance d. By applying the principle of similar triangle, the correction is the near peg is obtained, and the correction will be as shown. The permanent adjustment of level, the correct the staff readings on A as A1 plus C1, the correct the staff reading on B as B1 plus C2, then the crosshair is brought to the calculated corrected readings by raising or lowering the diaphragm by means of the diaphragm screw. The classification of level, there are different classifications like simple leveling, differential leveling, fly leveling, check leveling, profile leveling, cross leveling, reciprocal leveling, the precise leveling, trigonometric leveling, barometric leveling, and hypersonometric leveling. Simple leveling, it is simple difference between the 2 points. It is the simplest method when we have to find out the difference of elevation between 2 points. The differential level, this method is used to find the difference in elevation between points if they are too far apart or the difference in elevation between them is too much. The differential leveling, for that the different steps are to be followed. This figure depicts the way in which the differential leveling can be done. The fly leveling is just like the differential leveling carried out to check the accuracy of leveling work. In fly leveling, only back side and the fore sides are taken. So number of readings are only 2 and a number of can be obtained. In fly leveling, as I said, the difference between 2 only is to be obtained. So this figure clarifies the process of fly leveling. The classification of leveling, it can be check leveling, it can be profile leveling. For example, in check leveling, this is carried out to check the accuracy of the work. It is done at the end of the day's work, so that whether the work whatever has been done is properly checked or is proper confirmation. The profile leveling is done to taking the level along the center line of any alignment, maybe like road, the railway, the canal, etc. The object of the profile leveling is to determine the undulations of the ground surface along the alignment. So on a particular profile, on a particular ground, what is the profile that can be obtained with the help of this. This is the example of check leveling narrated with the help of figure. The classification of leveling can be cross sectioning, the precise leveling, or trigonometric leveling. For example, in cross sectioning, it is carried out perpendicular to the alignment at an interval of 10, 20, 30, 40 meter. This gives the idea to make an estimate of the earthwork. The precise leveling, it is used for establishing the benchmark for the future public uses. It is carried out high degree of accuracy using the advanced instrument. In trigonometric leveling is the method where vertical distance between points are computed by observing the horizontal distances and the vertical angle between the points. This is a figure clarifies the cross-sectioning method. This is the figure narrating the trigonometric leveling. Reciprocal leveling basically consists adopt accurately determine the difference of leveling between 2 points which are at a very far distance. It is also used when it is not possible to set up the level in midway between the 2 points where the observation is to be done. So, let A and B be the 2 points on opposite banks of a river. It is required to find out the level difference between the points A and B. To find it, set up the level very near to the point A, take the reading of A and that of B, let the reading be A1, B1. Next, shift the level and set up the instrument close to B and observe the readings of A and B. Let the readings be A2, B2, and suppose small d is the true difference of level between A and B, and the E is the error due to the curvature, refraction and imperfected adjustments. This is the figure which narrates the procedure that I just told. In reciprocal leveling, this is the instrument, the 2 points A and B and the line of collimation, the level line, and the readings are as shown. The errors in leveling. There are different errors which may occur in the leveling procedure. It includes the personal error, the instruments may not be leveled, the focusing of the eyepiece or the object glass may not be perfect, the parallax might have been there, the position of a staff may have been changed. I mean, instead of the location where exactly the staff was kept, it might be close by or might have been shifted. The entry or the recording in the field book may not be proper. The staff may not be fully extended and may not be held vertical. So, the reading with the help of a staff, if not fully erected, will be giving erroneous readings. Other errors due to natural causes, that is curvature of the earth, may affect. The effect of refraction may cause a wrong staff reading. There are some errors in the staff reading due to the high velocity of winds. These are the common errors in leveling. The foresight and backsight not being taken on the exactly same point, reading the staff upward or instead of the downward, reading of stadia here not taken properly, reading of wrong number of meters or the decimeters, entering the backside in foresight or vice versa, the transposing the figures and omitting any entry, the leveling staff not fully extended. The figure depicts the curvature and the refraction corrections.